Welcome back. This is Anoma Day, and I have some news for you. You have been deceived because I said kudos, but this slide says noodle. What will we be hearing about today? Well, Yulia will reveal that, as one does with the shielded resource machine.
Yeah, so just like Jonathan, who presented before me, I like analogies, but I usually go for more deranged versions. So today we're going to be talking about noodles instead of kudos. Okay, not true actually. We're going to talk about kudos. But so over the last 3 months I was writing this forum post about kudos, and I was not very successful in communicating what it is and why it should be, in my opinion, the way I thought it should be. So I thought if I present it and I talk to people, it will be a good opportunity to have a discussion about it and maybe resolve some confusions. Yeah, so Kudos application for resource machine. So I have a couple of warnings for you. It's a fairly low-level talk, and I assume that you already are familiar with resource machine basics like resource fields, actions, whatever, validity rules and stuff like that. And it's also not based on any higher level language, so it's all designed for pure resource machine. Yeah. So here's the plan. I'm going to talk about what a Kudo is in this application, then about the resource structure, how to ensure conditional transfer, then a bunch of examples, and then some concluding remarks. So a Kudo is what we call resources of Kudos application, and we define Kudos as resources that can be issued, burned, transferred conditionally, or swapped. So that is what we assume by Kudos. Nothing extra is implied. Kudos have subkinds, which we call denominations, and Kudos are also owned. So every resource belongs to some entity. So now that we get to noodles. So if Kudos were noodles, then noodles would be the main Kudos application kind, and different noodle dishes would represent different denominations like ramen, spaghetti, or naengmyeon. So back to Kudos. Kudos, every Kudo, every resource is governed by two logics. There is Kudos application logic, that is the main application logic, and it defines how Kudos of all denominations work. And there is denomination logic that specifies the rules that apply to specific denominations. And back to noodles. So Kudos' main logic would be that all noodles are made of flour and we boil them in water to cook. And for different denominations, different rules apply. For example, you slurp ramen and you don't cut spaghetti, and naengmyeon you only eat in the summer. Different denominations rules. Now you see that resource contains two logics, right? There is Kudos main logic goes to the logic field, and then denomination logic goes to the label field, and it also includes some extra parameters required by denomination logic. If there are no extra parameters, there are no extra parameters, just denomination logic. And owner of the Kudo is encoded in the value. So if you're familiar with resource machine now, you're wondering, how can we have two logics for one resource? So the answer is very simple. We have two resources. Yeah, so we have the main Kudo resource that has the Kudos logic in the logic field, as I mentioned, and then there is a resource that I call denomination logic trigger, which I'm going to call DL trigger because it's too long, and it contains denomination logic in the logic field. Because as we know that in actions, the logics that are verified are the logics from the logic field of a resource. Right, so that's how it works. So the Kudos logic ensures that the DL trigger is in the same action, and because it's in the same action, action verification rules ensure that DL is triggered. So this way you trigger both Kudos logic and DL logic. Now we have enough information to describe how issuing and burning Kudos works. So here we have a couple of action diagrams. On the left, it's issuing kudos. On the right, burning. They're pretty similar. So when we issue new resources, or kudos in this case, we create them from nothing, right? So we have the kudo resource that we're creating. This is the first resource, the first rectangle on top. Then the second one to balance the first one of the same denomination. And then, because our kudos logic requires the denomination logic, we also have DL trigger in the same action. So this way, DL denomination logic verifies the action, kudos logic verifies the action, and new kudos are issued. And the same thing works for burning. Basically, we are consuming a resource, and then we're creating ephemeral resource just for balance, right? And then there is denomination logic that governs everything. Any questions at this point? No, of course not. So I told you about denomination logics. Here's an example that we're going to use later. In this example, we have an owner of denomination. So denomination owner would be specified in the label, extra information. And so we have owner's identity in the label and resource owner's identity in the value, just like before. And the constraints specified by denomination logic are like this. So for transfers, we verify that the transfer is authorized by the owner of the kudo. So from the value field, right? And for issuance and burning, we verify that the action is authorized by the denomination owner. So just to get back denomination owner from the label, and transfer is authorized by the resource owner, right? So that's a non-edible denomination logic example. Now we get to conditional transfer. So just to remind what a transfer is when we consume a resource, and then we create an identical resource with a different owner. So everything is the same, well, up to a certain point of fields, but the meaningful fields that we care about that are represented on the slides are the same. It's just the owner that changes. So a conditional transfer is the transfer where the sender can only send kudos if the receiver allows sending them kudos. So now the question is, how do we check that the receiver allows it? So we have another logic that's called receive logic. Yes, so the properties of receive logic. It describes what transfers are allowed. It's associated with each kudos user, because each user is a potential receiver. It's carried by receive logic trigger, RL trigger, similarly to denomination logic, and it's also enforced by kudos logic. Here's an example. I only allow transferring kudos of specified denominations of quantity above 0. So if kudos were noodles, the receive logic examples would be that I only eat noodles with tomato sauce, or I'm vegan, so I only consume noodles that are do not contain animal products. And now, because naming suggests that there is some similarity, let's compare receive logic and denomination logic. They both are carried by trigger resource. So to verify extra logics, we need a trigger resource. They both are enforced by kudos logic, but there is a difference in what they are associated with, which is substantial. So denomination logics associated with resource subkind. So they are a part of a resource. And receive logics associated with users. And they're not explicitly a part of resource. Yeah, so that means we cannot enforce them the same way. So here's why, because you're probably wondering, why can't we enforce them the same way? So as you remember, resource kind is built from logic and label. So if we encode the receive logic in the label, it will change the kind of the resource, which is wrong semantically, because you don't want to balance based on who the owner of the current resource. You want to balance resources of the same denomination, right? So because of that, you cannot put it in label. There is another problem with that, is that the person who creates the resource for the receiver is the sender. And a malicious sender is incentivized to specify the correct receiver's identity, because that's how they send something to someone. but the malicious sender is not incentivized to specify the correct receiver's receive logic, which is a problem. So the difference is that identity of the receiver is on the system level. So we can verify and enforce the correctness on the system level. We specify identity, that means that the resource gets delivered to specific identity. But the receive logic exists on application level, which means we cannot enforce it the same way. So we can just reference a receive logic in the resource and consider it done. So the question is, how do we know that the referenced receive logic is correct if we want to add receive logic to verify the transition? So what we need to do is we need to authenticate the receive logic. And there is no point in putting it in the resource because we cannot use the resource fields that enforceable, like label and logic, and putting it in other fields just doesn't make sense because it's not enforced on the system level. So what we're going to do instead is that we're going to ensure, the same way like for denomination logics, we ensure that receive logic trigger is in the same action, then the receive logic verified because actions work this way. And additional thing we need to do is that we need to authenticate the receive logic to make sure that it belongs to the actual user. It's currently done by signature check. So at this point, I assume you understood this. I know it's a big assumption, but if you have questions, I can answer questions. But of course you don't. So now we have enough to explain how conditional transfer work. So conditional transfer is when the receiver authorizes the transfer. But of course we don't want the receiver to be online for that. So what happens is that the sender consumes their resource. In this case, the sender is A. Then the sender creates the resource for B, the receiver. This triggers the request for receive logic, which is yellow on this slide. And then there is denomination logic as usual, right? So Kudos mail logic makes sure that there is receive logic for receive authorization and denomination logic for everything. Yeah, so that's how we do conditional transfers. At this point, we can specify all the constraints that constitute the main logic. So it verifies that the DL trigger is present. And for transfers, it verifies that receive logic trigger is present. And then it also authenticates the receive logic. The receive logic that is specified by the receiver. So pretty small. The good news is that the last function that we want to implement with Kudos, we don't need to do anything for. It just works like for any other resource kind. So that's cool. Now we get to examples because I see you really want some examples. So this is just a reminder of the denomination logic example that we looked at before. Denomination has an owner. We verify the transfer by checking the owner, the Kudo owner authorization, and then issuance burn checked by denomination owner. And then reminder of the receive logic example that we only allow transfer in Kudos of specified denominations with quantity above 0. So the full example looks like this. We have a transfer here because we want to see how receive logics work. So Kudos logic checks that DL trigger is present, checks that RL trigger is present, and checks that RL belongs to B. B is the receiver. Then denomination logic example verifies that A authorized the transfer because A is the owner of the Kudo and we're doing the transfer here. And receive logic verifies that denomination N in this case is in the list of allowed denominations and that the Kudo that is transferred to B has quantity above 0. And in case this example was not clear enough, here is a bonus example. So if Kudos logic was the noodles logic, we check that noodles are made of flour and that they're boiled in water. Because we're transferring ramen, we check that it's slurped during consumption pun intended. And receive logic verifies that the ramen is vegan because the receiver is vegan, right? So makes sense. So now some remarks about the advantages of this design is that it's designed to be easily extensible. Denomination logics are independent from each other and Kudos main logic. So you can create new denominations and this will not affect the Kudos main logic or other denominations. And it's the same for receive logics. They're fully custom, so users can specify what the constraints are, and they're also independent from the main Kudos logic. It's completely independent. It's also shielding friendly because we want everything to be shielded. And we also have some design implementation separation so that we make some decisions about the extensibility not based on how slow it is, which obviously affects the implementation and it becomes slower and slower day by day. But it's a separate concern, right? So more work to be done. There are a lot of questions on how to maintain and distribute the receive logics because we don't want the receiver to be online all the time to authorize transfers. That means that they communicate their receive logics. But at the same time, we kind of want it to be shielded, so we don't want to communicate them to everyone. And at the same time, we kind of like want to update it sometimes, and how does it work exactly is not clear. There's also a point about kind of total authorization abstraction when we only have relations between resources in the Kudos logic, which is currently not the case because we use signature check to verify the receive logic. Apparently, it's very difficult. So this is for future. Yes, another question is how to validate created ephemeral Kudos because how we trigger receive logics. We trigger them for created Kudos, but created ephemeral Kudos only exist for balancing. So nobody received them really, but we still have to kind of make sure they're authorized, right? So there are some questions to answer. And another thing we haven't done yet, but we want to do is to have a shielded Kudos implementation that has all of the privacy perks like function privacy, private solving, shielded state sync, and everything else that we can have private is private. So yeah. So this is the QR code that leads you to forum post that summarizes the state of shielded Kudos and leads you to all other posts about shielded Kudos. And now I'm ready to answer your questions. I hope you have a lot.
Thank you, Yulia, for telling us all about shielded noodles. I mean, kudos. Any questions from the live studio audience? Jamie.
Hi, thank you for that lovely talk, Yulia. As always, you remind me of how much I don't know. I don't know how Kudos differs from other kinds of resources. I don't know why you would want to create them and what purpose they serve, but those aren't my questions, they're just notes. There's clearly something potentially beautiful here. I'm not saying anyone should go to the time and trouble of creating it, but there are things and they can move around, and these things have an internal logic about how they can be used, and there's a dual external logic about how they can be received. And then you touched briefly on the fact that receiving is non-trivial because some participants might be asleep when stuff arrives. So I felt, for me, this talk was quite implementation. I mean, this seems to be coming from an implementation, but there's clearly a structure here, and I'm a bit frustrated because I don't know what that structure is, but it's clearly a thing. Does that make sense? There's a thing there, and I don't know what its shape is.
So, first of all, thank you, Jamie, for the question. It's great that I can always rely on you, because it would be too sad if I had no questions, which I kind of expected. Second, I'm not sure what you mean exactly about the structure. I would not call this talk implementation talk because I think for me it was like very clear goal to separate implementation from the design, but it is, I guess, lower.
I can give an example.
Okay.
Why I didn't mean well. So there's two kinds of owners. There's the owner of the type of the resource, and there's the owner of the Kudos itself, right? And they both contribute to the logic. So this raises a question of, this is clearly a modal system because stuff is moving around, right? It has a sense of place. So one very basic question is, what is the structure of places? If I have a Kudos, is it located at its owner, or is it perhaps located at the cross product of the owner of the Kudos and the owner of the denomination to which the Kudos belongs?
You have to define what it means to be located.
This is a mathematical notion of location. It's just in modal logic, stuff exists in a place, and then the question is, what is your notion of place? And it's not clear to me from this talk what the best notion of place would be. I don't mean to monopolize the questions, I'm just responding.
There are no other questions, I'm sure. But it's a good question, but I still don't understand what it means to exist in a place. Because here, if existence means that a resource is kind of, how do I say it, like, it requires certain parties to manipulate the resource, if that is the existence. So like, if resource exists, you know, at my place, let's say, I fully decide what happens to the resource. Would that be true? In that case, then it exists at three places at once. So it exists at the Kudos logic place, denomination owner place, and resource owner place, because all three are involved in deciding if something happens to the resource or not. Although the resource owner, it depends on the specifics of the denomination and specific and to the transaction function, but the Kudos logic and denomination logic always define if something can happen to the resource or not. And if one says that something cannot happen, then nothing happens. So it's kind of like the conjunction.
Thing. So this kind of question, so the way this game is played is that we try a notion of place, which you suggested might be a triple, and then try to write down a logical system that describes how Kudos moves around. And it'll either work elegantly or it won't. And it would be fascinating if it turned out that maybe two out of these three things naturally define a possible world, that is, a place, whereas the third one might naturally live in a different level, like some global logic, some global rules about how stuff can move around.
I see what you mean. So this global logic would be the Kudos main logic and denomination logic and...
for example.
Yeah.
It could be. And then the guide is what leads to the most compact, elegant system. It's always possible to hack these things up, but the maths will tell you what shape it wants to be.
Yeah. I mean, that's definitely not the perspective from which I approached this whole thing, so I'm not sure I can instantly map the definitions here right now. So I'm not sure how to continue.
A good question for the future, for sure. And we do have another question. Yes. Michael.
Hi. I was wondering, in the denomination logic, there's currently no, or maybe my question is there a way to constrain or fix the supply? And have you thought about fixing the supply of Kudos denominations?
Yeah, I'm sure. So you basically can constrain the supply the same way that you constrain supply. You just specify it in denomination logic, like attach it to commitment or nullifier, whatever you encode it in the resource, and like base it on that. I don't fully remember it, but I don't see why it wouldn't work in this specific case, like the way you defined it in your application.
Yes, a third question, Tobias.
A quick question. First, you said something about sub-kinds or sub...
Yes.
Yeah. So we had two logics in this talk, right?
Yes. Well, many. But
so,
yes.
So we used to have one logic. Now you're telling us about two. So
yes.
The next step would be like having three logics,
You already can
right?
have three. You already can have three in parallel or hierarchically, whatever you want.
Hierarchically. So yeah, okay, thanks. That's the answer to the question actually. Or the question is like, could you do this also in a hierarchical manner? And then the follow-up question would be like, do we have an example where this makes sense, or is it just like we have the technology and we'll eventually find out what it is about?
So the thing is that the same structure that you have for splitting Kudos logic and denomination logic, you can apply it again to denomination logic. So that denomination logic acts as Kudos logic, and then you have another denomination logic, and this way you have like two-layer hierarchy. So there is no preventing things from that.
All right. Thank you to the audience for those lovely questions, of which there were many, despite predictions otherwise. Thank you to
I'm
Yulia
really
for the
happy about
lovely
that.
talk.